If you've been following along in the SIEG 7x14 review series, you may have wondered what happened to the tailstock. But the truth of the matter is I got busy with some personal projects that I was having a lot of fun with, and time kind of got away from me. But it's now time to get back to that, and I want to finish up this review because in the wings here I have a new SIEG mini mill that I want to do a YouTube review on. So let's get this one done and get that one started. Let me zoom in here and we'll talk about the tailstock. Alright, well, most of the time the tailstock is set up with a drill chuck in it, as you see here, but there are other types of accessories that can be mounted in the tailstock quill, and we'll take a look at some of those. But the this part here that extends in and out is called by various names. It's sometimes called the quill, Q-U-I-L-L, or sometimes called the tailstock ram, and sometimes called the tailstock spindle. So you may see it referred to by any of those names. But it's hollow. It has a Morse taper number 2 cut into it, so you can mount Morse tapered tooling in there. And of course, Morse tapers, if you're familiar with them, are kind of a long, shallow taper that is self-locking, which is to say when you mount tooling in there, the friction between the inside taper and the outside taper holds the tooling firmly in place, and ideally without it rotating or slipping. Now, the spindle can be moved in and out by turning the tailstock hand wheel, and as I turn it counterclockwise, as looking from the right end of the lathe, the tailstock quill or ram moves inward, and as I turn it clockwise, it moves outward. If you keep turning it all the way inward, eventually it will bump up against a stop inside here. The end of the taper on the tooling will hit that stop and force the tapered arbor to come out. So that's how you remove tapered tooling from the tailstock, is you just crank the tailstock all the way back and until it pops out. And when you want to reinsert your tooling, you have to extend the quill out maybe a quarter or half an inch to the, there's a graduated markings on the quill, and position your tooling in here, and then you just give it a good whack with your hand, and that locks it up just due to the friction of the two tapers coming together. Now, of course, if you had a live or a dead center with a point on it, you probably wouldn't want to use your hand to do that, but I think you get the idea. Now, the other control here is a lock for the quill, and there are situations where you want the quill to be permanently or rigidly locked in place while you're completing an operation. And an example of that would be is if you're using a center here to support the end of a workpiece, you would want to keep that locked. I'll show an example of that in a few minutes. But you can unlock it just by rotating it, or lock it by tightening it down, depending on what type of operation you're performing. Now, if you're drilling, obviously you want to be able to have the quill move freely in and out. But if you were using it as a support for a long workpiece, you would want that firmly locked down. This control is the tailstock cam locking lever, and when you move it forward, it unlocks the tailstock so it can slide freely back and forth on the ways. And if you firmly press it down, moving it to the right, it locks up and keeps the tailstock from slipping or moving, which you would want in quite a few situations. So if everything's adjusted properly, it takes very little pressure on this lock to lock it up, but you can, if necessary, go underneath here, and there's a nut you can adjust to change the position at which this lever locks up. So you may have to tweak a little bit and adjust that nut to get the angle that you like here, you find most convenient for your operation. And you can see there's a little arm that moves up here, and there's a fairly large amount of leverage involved that causes that locking action to be quite tight. So that's a great convenience feature. There's a lot of mini lathes around that have just a nut here and do not have this locking lever, and for those types of lathes you have to actually use a wrench to loosen the nut, and then position the tailstock where you want it, and use the wrench again to tighten the nut. And that can be awkward because sometimes as you get up close to the cross slide, the nut can actually be sort of back out of the way here. I'm having trouble getting the tool far enough back here. But as you can see, if you had the compound swung around here, it can actually be kind of awkward to get access to that nut. So having this lever here eliminates the need for the nut and the wrench, and is a nice convenience feature. So something to think about when you're making your choice of lathes. I wanted to zoom in here and give you a closer look at the tailstock ram, and as you can see, there are divisions etched into the ram in 1/16 of an inch, and then the larger divisions here are 1/8 of an inch, and then of course the 1/2 inch mark there. And if we bring it out a little bit more, you can see there's a 1 inch mark and so forth. But these are very handy if you need to drill a hole to a particular depth. Let's say you wanted to drill a 1/4 inch hole, or a hole that's a 1/4 inch deep. You would position the drill bit in your chuck and move that up to the end of your workpiece, zero out your tailstock ram, and then when you begin drilling, you can just keep an eye on those divisions, and when you reach the 1/4 inch mark, then you would stop. So that's useful if you just need an approximate depth, but if you need to drill to a more precise depth, for example, if you were drilling a counterbore using a milling tool to get a flat hole, or a hole with a flat bottom rather than a conical bottom as you would get with a drill bit, well then you could actually count turns of the tailstock hand wheel. Now on some mini lathes there actually are graduations here on the collar surrounding the tailstock hand wheel, but I don't see them on this lathe. But nevertheless, you can do a test with a dial indicator or just using the scale and figure out the pitch of the tailstock lead screw. And once you know how much the ram advances for each turn, you can just count turns to keep track of how deep you're drilling the hole. Now, as I mentioned earlier, the typical Jacobs style chuck, as you see here, is probably the most commonly used accessory in the tailstock, but be aware that this does not come with the mini lathe. You have to purchase it separately, and that depends on the vendor. There are some vendors that may include a tailstock chuck, but others do not, so you'll need to check the specifications of the lathe. But this particular one from LittleMachineShop.com, the chuck and the arbor for the chuck have to be purchased separately. So look on the LittleMachineShop.com website and you'll find out the specifics there. But another thing to be aware of is that the arbor on these chucks is shorter than a typical Morse taper number 2 arbor. And if you buy just an ordinary Morse taper number 2 arbor, you will probably find that it extends out here farther than you want, and that may have the effect that when the chuck is seated in here, you can't get all the way back to the 0 division. If you go too far back, it'll pop the chuck out. So having this short arbor is desirable, and I recommend that you just find the one on LittleMachineShop.com and purchase that, and you'll avoid that problem. Now you can see here this is marked, or maybe you can see, maybe not. It is marked with some specifications here that show that it's a Morse taper number 2, and then the corresponding taper that mates with the chuck is a JT33, or a Jacobs taper number 33. So different chucks have different tapers in them. There's a taper on the other end here which is different from the Morse taper, and so you need a taper that matches the Morse taper here, but you need a taper on the other end that matches the particular chuck that you're buying. So be aware of that when you're selecting arbors and chucks. Make sure you get the correct arbor that matches your chuck and on the other end matches your Morse taper number 2 tailstock. Let's look now at some other types of tooling that can mount in the tailstock. So we'll pop out this Jacobs chuck that's in here, or Jacobs style chuck I should say. It's not a Jacobs brand name. And you can actually get drill bits that have a Morse taper on the shank, and they're usually used for more specialized applications because they're fairly expensive to buy because of the shanks on them. but in heavy-duty machine shop operations, you'll sometimes find these. This is one I had around for a special application, and it happens to have a Morse taper number 1 shank on it, so it's too small to fit in here directly. But you can buy adapters such as this that has a Morse taper number 1 bore and a Morse taper number 2 shank, and then you can pop your Morse taper number 1 drill bit in there, and it will fit into the Morse taper number 2 tailstock. Now I have to crank this out pretty far because this one has a long shank with this tang on the end. And some lathes have a mating gap for this tang to keep the drill bit from rotating. And in fact, there is one in this adapter here that mates with the drill bit tang. But I don't think there's one inside the, no, there is not one inside of the ram on the mini lathe tailstock. So that's kind of a specialized application, but I just wanted to demonstrate that or illustrate that so you'd be aware of it. Now here's a handy tool that I use quite often. This is also from LittleMachineShop.com, and it is a die holder, and you can put a round die here, a 1-inch round die. This one happens to be a 1032 thread pitch, if you can get around the glare here. But as an alternative to cutting threads with the thread cutting tool, a lot of times it's quicker and a lot more convenient to just use a die to cut the thread. And you put your die in this holder here, and it can slide freely back and forth on this shaft. In fact, you can slide all the way off. But in use, you would bring this up to your shaft that you want to thread until it starts to make contact, and then either gripping it with your hand or using some sort of a little lever here in this hole to gain more leverage, you would start to advance the die until it grips onto the surface, and then of course it will tend to feed itself outward. And then you can either turn off the lathe or you can just remove your lever bar from here, and this will start to rotate freely when you reach the end of the cut. Then you can back it off and repeat it to clean up the thread and so forth. But it's a quick and convenient way for cutting external threads, so you might want to purchase one of these if you intend to do a lot of that type of work. Now for cutting inside threads or internal threads, you can simply mount a tap in the Jacobs style chuck, and you have your pilot hole drilled into the end of your workpiece. You just advance the tailstock up. You have to make sure the chuck is tightened up so that this die or tap does not rotate. So I don't have it tightened up enough now. But when you bring it up, it will start to cut threads, and as it does that, will draw the tailstock into the hole. So the tailstock has to be unlocked and free to move, so it'll be pulled in as the thread is cut. Then you have to watch carefully so you stop the lathe before you hit the end of the hole. And then you can reverse the lathe to back the tap out, which is very convenient. Now another piece of tooling that's commonly used in the tailstock is called a center. This particular one comes with the lathe. This is a Morse taper number 2 dead center, and it's called a dead center because it does not have any ball bearings associated with it. It just simply sits there statically in the tailstock once you mount it in there. So you got to sort of pop it in from the edges, being careful not to gouge your hand out on the point. But once it's in there, it can be used to support the end of a long limber piece of stock, and I'll show you in just a minute how you would go about that and why. But there's another similar type called a live center, and it serves pretty much the same purpose, but it has a ball bearing race in it, and because of that, when the live center is mounted in the tailstock, the pointed part can turn freely on these bearings. And again, I'll get to that in a minute, why that's a more desirable type. Now, the situation where you might want to use a live center or a dead center is when you have a long, relatively long and limber piece of stock like this. Anytime the stock is longer in length than about, say, 3 or 4 times its diameter, and is projecting out from the chuck, this end here tends to be somewhat flexible. And if you start to turn this, the cutting force from the tip of the tool will actually push the workpiece away from the cutting tool, and instead of ending up with a nice round or cylindrical workpiece, you're going to end up with a tapered workpiece. So to avoid that, what you do is you drill a little pilot hole in the end here and use either a dead center or a live center to support the end of the workpiece, and that center creates a point of support so that the cutting tool no longer forces the workpiece away from the cutting tool, and therefore you get a cylindrical piece rather than a tapered piece. So we'll take a look at a minute here how you cut that hole in there and show an example of that. So I've set up my Jacobs style chuck in the tailstock, and I have here a little tool called a combination drill and countersink, or center drill and countersink. And these are used typically for drilling a short conical hole in the end of a workpiece so that you can place the point of a center into that conical hole. So let me tighten that down and then we'll do that. Alright, next I want to make a facing cut on my end of my workpiece here. And that will give the drill a nice clean surface to drill into. See if I can get that to focus on there. So I'm going to start up the lathe. And I've got the carriage locked down. And I'm now going to advance the tool a little bit and just take a light facing cut. There we go. So I now have a nice clean face on the end of the workpiece. And then I'm going to drill into that with the center drill. And now we'll go ahead and drill our pilot hole. Alright, and that's all we need, and that just provides a nice smooth conical hole for the center to seat into. Now for the purpose of drilling the hole, I wanted to move the workpiece back into the chuck so it'd be stiff and rigid, but now that I'm ready to set up for my turning operation, I'll go ahead and advance it out more along its full length here. And so this is when you want to use the support from the tailstock, now that we have this long limber end sticking out there. And I'm going to put in my dead center to start with here into the tailstock. And again, I'll just pop that back in there so that it seats. And I'll bring it up, bring the tailstock up until the point of the center just about enters the work. Then I want to lock my tailstock down and bring this up until I get kind of a snug or firm contact with the workpiece. Then I'm going to use the tailstock ram locking lever to lock the ram in place. So this is when you want the ram to be fixed in position, and use the locking lever along with the lever here to lock the tailstock to the ways. So now we're set up, but I want to use a little oil or some grease in here because the workpiece is going to turn against this tip of this center and generate friction and heat. So when you use a dead center, it's important that you put a little oil or grease on the end here to avoid that friction. You get some serious heating that can potentially damage your tailstock center. Here's an example of a different live center. This one is a higher quality and heavier duty version than the smaller one we looked at earlier. And I tend to use it more on my larger lathe because it's a little bit longer than I would like on the mini lathe, and it takes up some of the space between the headstock and the tailstock. So a nice short one like this is better on the mini lathe just because it takes up less room. This particular one came with my very first Harbor Freight 7x10 mini lathe that I bought back in 1999, and I've since decommissioned the lathe, but I still regularly use this live center. Now here's a specialized live center known as a bullnose center, and as you can see, it has a very large diameter tapered face on it, and that's real handy if you're working with cylindrical type of material and you need to support the end of the cylinder to keep it from moving around while you're trying to machine it. So these are some examples of more specialized tooling, but there are plenty of situations that you may run into where something like this can mean the difference between getting the job done and not getting it done, or getting it done safely and not getting it done safely. So that pretty much wraps it up for the tailstock accessories. Now let's look at one more feature. Let's look now at a specialized feature of the tailstock. If you look carefully here, you can see that the base of the tailstock actually is made up of two separate parts. There's a lower part here which rides on the ways, and then there's an upper part which actually supports the ram. And there's a gap in between the two and a guide that's machined into this lower part. And around back of the tailstock, you can see that there's a set screw in here. Let me see if I can give you a better view of that. But that set screw is a locking screw, and if you were to loosen that with a screwdriver, as you can see, it's sort of been painted over, but you can loosen that with a screwdriver if you chose to do that, and once that is loose, you can actually slide this upper part of the tailstock forward towards the operator or backwards towards the rear part of the lathe or back towards the chip shield, and offset the upper part of the lathe or the tailstock relative to the lower part. And the reason you might want to do that is it allows you to turn long tapers, or a tapered workpiece that's fairly long, and effectively it shifts the tailstock end so that the workpiece is now canted or angled from front to back. And of course, when you cut it, if I had it angled like this, it would get narrower as I approached the tailstock end. So that's one way you can cut a long taper. You might, for example, want to make a tapered handle for some sort of tool that you're making, or for some other type of instrument or whatever. But it's one way you can cut a long tapered piece on a lathe. Now the disadvantage of it, and there are several, one is that the workpiece is now held at an angle between centers, so that the point of the tailstock no longer sits in there directly, or I should say the point of the center no longer sits smoothly or evenly in that pilot hole that we drilled. So that creates a little bit of a problem. But the other thing is that you've now offset your tailstock from its zero position, and the next time you go to use the lathe and you want to just turn a cylinder, you may find that it's not quite centered the way it should be, and what you thought was going to be a cylinder turns out to be a taper. So anytime you offset the tailstock, you have to go through a procedure to make sure you get it lined up properly end to end, so that you don't end up turning tapers when you don't want to. And one way you can do that is to put a dead center in the tailstock and a dead center in the headstock, and bring the 2 points together, and that will get you pretty close. You can move the tailstock back and forth until the 2 points match up, but that's not a very precise way to do it, but it is one way. So my comment on that is, I don't generally recommend messing around with offsetting the tailstock. There are other ways to turn long tapers that avoid that, and it tends to be kind of problematic. So I like to leave mine alone and just leave it set as it is at the factory, assuming that it is properly on center. While we're on the subject of offsetting the tailstock, I thought it might be constructive to look underneath here at the bottom side of the tailstock, and you can see there's a groove here that rides along the raised part of the ways. And underneath here is another locking screw, so if you're planning to offset the upper part of the tailstock, you also have to first loosen this locking screw here, and of course remember to tighten it when you get the tailstock position the way you want it. And then when you go back to zero it, you need to loosen that again, and remember to retighten it when you've got everything back zeroed the way it should be. Now this little clamp here is the metal plate that clamps up. It raises up when you move the tailstock locking lever, and it clamps onto the underside of the ways to hold the tailstock locked in position. And I mentioned earlier that there's an adjusting screw here, and this spring tends to keep, or its purpose is to keep pressure on this plate so that it locks up more evenly and doesn't flail around and gets jammed in the space as you're moving the tailstock back and forth. But this screw here can be adjusted, and if you tighten it or loosen it, one effect that it will have is to change the relative angle at which the tailstock handle locks up, the locking lever. So you may find that you want to tweak this a little bit in or out and set the angle of the tailstock locking lever to whatever position you find is best for your working style.